Welcome everybody to question 5. We're getting towards the end of the exam now, a little bit trickier questions, and a question that my teacher used to call completing the square. Completing the square. Now, I don't know what he meant by that, but I do know how the method works. I know how to do this, so let's dive right in. Now, he told us to get this question into this form. Ignore the +2 there. Ignore that for now. We'll deal with that later. Let's just focus on these two brackets. Let's times them out so we get a quadratic out of it. So we get x squared minus 5x minus 3x is minus 8x plus 15, and then we just have this +2 over here. Let's not worry about that for now. So the way to do this is we take this number here, minus 8, and halve it, and say x, then minus 4 is half of it, so minus 4 squared, then we take away the square of this number. So minus 4 squared is 16, so we take away 16, then our plus 15 comes down here, and the 2 comes in here as well. So we get plus 15 plus 2. So I'm not going to go into why it works, but minus 8, halve it and take away the square, and then deal with this extra bit at the end. You may have put those together already. Doesn't matter if you did, doesn't matter if you didn't. But we can sort it all out now. So we have x minus 4 squared, then minus 16 plus 15 plus 2 is plus 1, and that is our answer. So if you want to prove it to yourself, you can actually times this out. You can say x minus 4 times by x minus 4 plus 1 and see what you get. Chances are you're going to get what you started with at the beginning. So let's move it on to the next one. Let's get some space there. Good. So, question B, sketch the graph. Oh, but you love these by now, sketch the graph. So, let's get our axes straight-ish. And another one there. So, we've got x and we've got y. And we've been told sketch that graph. Now, I shouldn't have deleted what I'd written actually, because what was it? X minus 4 all squared plus 1. So, the way we know how to sketch what we've got, and the minimum point and the point where it crosses the y-axis and all that, the way we know how to do that is we say that x behaves in the wrong way. The wrong way. And y, or if you can imagine this equals y, so the x bit, that behaves in the wrong way, and the y bit, that behaves in the right way. So my teacher said naughty x and well-behaved y. I just say wrong and right. So you remember it however you like, but the point is that your regular x squared that does something like this, your regular x squared, that gets shifted by 4 and by 1. The reason it's not minus 4 is because x behaves wrong. So whatever you have in there, times it by minus 1. So if it's x plus 3, then you get minus 3. So you want to move it by 4 in the x direction and 1 in the y direction. So we're going 4 to the right and 1 up. So that's my phone going off. So 4 to the right and 1 up. So let's draw that out if we can. Here we go, like this. Something like that. It's going off again. Something like that, right? So this point here, this is going to be 4. This point here is going to be 1, which makes this point down here the point for 1. And we also get told to know what that point is there. We get told to state the coordinates of that point. That point, if you think about a normal x squared graph, then you're going, what is, okay, 4 this way, and then up like that. Well, 4 squared is 16, and you go up by 1, so plus 1 is 17. So this point here is going to be 0, 17, because it just follows the same rules as an ordinary x squared graph. So that's all we're being asked to do, and we've done it. Great. So the next one, write down the equation of the tangent at its vertex. This point down here, use a different color, use red. This point down here, that is the vertex. The vertex is the place where it changes direction. So the tangent to the vertex is going to be this long line across, something like that. Okay, it's just this flat line. And a flat line where x never change, or where y never changes, sorry, where y never changes is y, hang on, here we go, y equals 1. I know it's not quite on that line, it should be on that line, but y equals 1 is our tangent because it goes through that vertex, and stays like that. So, stays like that the whole way, that's just a tangent to the graph. Let's move on. Let's move it on to question C, and I love this question. This is such an easy giveaway of marks every year. So describe the geometrical transformation. Describe that. Now, we just did that actually. Geometrical transformation means how have you changed y equals x squared to get this long thing that looks ugly? How have you changed it? Well, we know how we changed it. We just sketched it and defined some rules for it. We moved it 4 places to the right and 1 place up. So that's what we'll say. We did a translation. Here you go. This is why I like the question. Translation, 1 mark. Then you say it's been a translation of 4 in the x direction, another mark, and 1 in the y direction, another mark. 3 marks there for doing 30 seconds or less of writing. Fantastic question that. That's 5 done. I'll see you